Hello everyone, this is Dayu Wang. Today I'm gonna present our project of the Wisdom Restaurant Recommendation System. Okay, we are team 5, where our name is Wisdom. So before we start, let's talk about our motivation. Why we choose the restaurant as our topic and why we use that. Okay, so restaurant is directly related to eating, and eating, what to eat tonight, this question is considered the most quotation difficult question all over the world because no one knows the exact answer. And then the question had been asked for the most times, okay, said by New York Times. So which means this topic is very popular. It is always the long-standing, the most popular topic all over the world. We have a lot of different kind of food all over the world, and how to choose the food for a specific user is kind of challenging because the user never provide a complete information about what he or what she like. So that's why we need to build a very good natural language, knowledgeable application which can help choosing a restaurant. We have, in the technical part, we have a lot of APIs, Yelp, Google Places, etc. And then from the customer reviews, we can perform natural language. We can deal with natural language because the customer reviews will determine if the restaurant is good at food, good at service, or bad ambience, bad environment. So in this case, so it is kind of challenging. In technically, we can do the natural language processing. Next, I'm going to briefly explain the architecture of our system. Our system's architecture is divided into two parts. The first part is the data training model. The data training model, we first grasp all the customer reviews, and then we perform an NLP. After that, we generate the feature vector by using TF-IDF and by using LDA. So another thing is we are doing the relation analyzer because we need to know that chicken belongs to food, and fish belongs to food, potato belongs to food. So if they are talking about potatoes, they are talking about food. Otherwise, like cockroaches, flies, that belongs to the ambience. If they are talking about cockroaches, that they are talking about the ambience. So after we collect those information, we put it into our ontology processor and generate the ontology results. Those results will be used as our trained data model. The second architecture down here is the real application model. So this application has a layered design. In the bottom layer, we have the basic algorithm and then the web handler. For the intermediate, we have the correlation learning model and user input handler. In the top level, we have correlation learning model again, but they are a little bit different. In the medium layer, our correlation model is kind of a self-adjustment. It's kind of isolated model, self-adjustment model, because this model studies. It is actually a machine learning model. It changes itself by passing more and more data. But this one, the correlation model, is used to change some restaurants' data. Because if the restaurants, most of all the reviews, they are talking about the food, but none of those are talking about ambience. But it doesn't mean the restaurant's ambience is very ugly. Even though if the food is good, we can say that the ambience, it won't bad, right? Make sense? So this correlation model is kind of use our manual interface to correct some data for a little bit. And we have the UI in the top layer. So there are a lot of restaurant recommendation systems. Why our system can be distinguished from other systems is because we use the Pentagonal analysis, which is kind of a novel idea used for recommendation system. We can see this picture, it maybe describe a basketball player. We have the speed, height, we have the strength, we have the accuracy, shot accuracy, or something like that. So, but in this case, we use the same idea. We divide the rating of the restaurant into a pentagonal. There, each corner represents food, ambience, service, cost performance and popularity. So different corners will have different values. You can see the shape in the middle, that this shape describes the restaurant. So we have the data processing rule, and we have the comparison rule. We use the satisfaction model to see how this restaurant satisfies a user request. We can use all other general rating like standard deviation. We can use this kind of analysis as well. So the last part, I'm gonna do a demo. So our demo will be a web application. We use Scala Java to implement the entire application, and then we use SBT library dependency for Java and Scala, and we use Maven for web. So also we use our platform is IntelliJ IDEA Ultimate version. With the web server, we use a Tomcat. So our data sets, our original data sets, it contains about 200K restaurants. It's too big for today. So our demo data size will be about 2K restaurant. So it's fair enough because our algorithm is very fast. We expected the running time to be less than 10 seconds. And then we use Webpack as our UI. Okay, let me show a demo for you. So first, we open the code and we build the server. So it takes just a little bit. Oh yeah, it connected to the server. So it will see our page, the main page of our restaurant system pops up. Then we can type something here. Let's say we like to see let's say pizza in San Francisco. Okay, but let's say this one, and then it also gives some options. So do I need breakfast, lunch, or dinner? Let's say dinner, and then the price is no higher than $2. I mean degree 2, medium. So let's click this. Complimentary Wi-Fi service, please. Under 600 calorie entree available. Definitely pizza. If you are eating a pizza, you don't expect under 600 calorie dish, right? So and then we click to find a restaurant, and the system now is running to find the restaurant in our database. So it should be pop up the result for less than 10 seconds. So let's see. Okay, we got the list of restaurant. Look, it's in San Francisco. It's in San Francisco, and then look at this. It's food, 5-star food, 4.76. It's kind of okay. We totally recommend 8 restaurants from our restaurant list. So then I think this is a successful web application we have built. Thank you so much.